So the last time that last question that I did, yeah, I tried really hard to actually figure out if there's, I mean, a way to actually do those kind of questions. And no, I just couldn't figure it out. Yeah, I think guess check is the best thing that you can do for those questions. If there is some method, yeah, I mean, I would really like to learn that method, but yeah, we don't have that right now. Anyway, let's continue. In chapter exercise 4. First question. Consider the following functions in their default domains. So 2 power x minus 1 upon 2 power x plus 1, whatever. Okay, this is always defined, like, okay, this is, yeah, for all real values. Okay, x squared plus 1 upon x sine x, right? Only at x equal to 0 is this not good, or wait, actually not x equal to 0, it's a lot of points. So n pi, basically. X equal to n pi, this will be not defined. So the numerator is always, positive and whatever this is. Okay, let's look of 1 plus x upon 1 minus x. X equal to 1 is clearly not possible. And otherwise, this thing can be written as, so it's like, what is this? 2 plus x minus 1 upon 1 minus x, which is 2 upon 1 minus x minus 1, maybe. Yeah, sure. Right. So this is inside a natural log. What does that mean? This must be positive. Okay, maybe this is not the best way to do that. Maybe this was the best way originally. So yeah, that's what I should have done, which means x plus 1 upon x minus 1, that's negative. So x belongs to negative 1 to 1. Both not inclusive. Okay, so that's this domain. Which of the following, okay, which of these are odd? Wait, you don't have to figure out the domains, fine. Just which of these are odd? Well, this is even for sure. This thing is, maybe like 1 minus 2. Oh, hey, yeah, I mean, that thing actually is odd. Fine. So 1 is odd because this is like, okay, 1 minus 2 power x upon. You get the idea, right? Just 2 power negative x minus 1. All that stuff. So you can write this 1 minus 2 power x upon 2 power x and then upon 1 plus 2 power x upon 2 power x. This cancels. Yeah, it's odd. So first guy is odd. What else is odd? This is not. This is, yeah, it is in fact. So this thing is basically natural log of 1 plus x, wherever it's defined, minus natural log of 1 minus x, right? So when you put, instead of x, when you put negative x, right? This is going to be just natural log of 1 minus x plus natural log of 1 plus x, which is, yeah, I mean, like, add these up, it's going to be 0. So sure, it's odd. No, not all 4. Second one is not odd. X e power mod x plus cosine x, but okay, this guy is even, but this is odd, so odd times even is still odd. So fourth is odd, third is odd, first is odd. So these the answer. Next question. Second. Okay, f of x is an even function and g is an odd function. Which of the following, if defined appropriately, must be an even function? What is this? This is y equal to f of x. This is a, and where is g of x? What is this graph represent? Why are we given this? What is this? It's like some kind of parabola. It's y equal to x, and this is y equal to, what is this? Okay, whatever, maybe this is not important to this question, right? Which of the following must be an even function if defined appropriately, whatever. So f of x plus g of x, no, it should not be like necessarily an even function. It can be. Okay, no, that's just not correct. I mean, okay, only if, yeah, no, it cannot be an even function. No, this is odd, of course. This is, what is this? So g of x is an odd function, right? And f is an even function. So g of negative x is going to be negative g of x, but f of negative g of x is just f of g of x. So it's the same thing. So d must be necessarily an even function. Next question. Third, odd extension of f of x is equal to x squared plus sine x plus natural log of x. So f goes from 0 to infinity to real. Then, okay, so for that guy, I just have to make this negative, right? So yeah, like negative x squared, because it's, yeah, okay. And then plus sine x because we want that part to be negative of what it usually is in the positive. Yeah, you get the idea. So plus sine x, and then, well, natural log of x is not defined for negative numbers. We want to make this negative, let's deal with mod x or something. So natural log of mod x, but then negative of that. Yeah. Or you could just say negative natural log of negative x. That also works. Yeah. So this looks good. No, this doesn't look good. What is this negative natural log of negative x? And then, right. So the way to do this thing is, instead of uh, right, instead of x, just put negative x, right? So, uh, come on, what am I trying to do? It's the odd extension of that guy, right? Mhm. So since x is in the negative domain, just instead of x, put negative h. This is going to be like h square minus sine of h plus natural log of negative h, right? That's what the function would be if it's in the oh come on, what am I doing seriously? There's no way to be thinking about it. Okay, maybe I should, do this something like this. So there's a value x naught in the 0 to infinity domain for this function f of x. At that point, you just got y being equal to, so y of x naught, that's equal to x naught squared plus sine of x naught, whatever, plus natural log of x naught. Now what we want is, okay, you know what? Let's not use x naught. Let's use, do I really have to tell what I'm doing? I guess I have to because I'm teaching this thing. Why not? Okay. So f of x is this thing. Why am I writing this down? Right. So, okay. Now listen to me. What we want is an odd extension. What that means is that like negative infinity to 0, we want a function, let's say g of x, such that for some x in this domain, so let's just say x is equal to x naught, right? For some x naught in this domain, for negative x naught, like, okay, so g of negative x naught, because negative x naught will be in this domain, right? Negative infinity to 0, right? This thing, that must be negative of what f is, right? So negative f of f of x naught, right? And then this should happen for all values of x naught. So what that basically means is we want a function such that g of negative x, right, where x is actually a number in the domain of f, this thing is equal to negative f of x, right? So for all x in the domain of f, right? But what that means is, g of x is equal to negative f of negative x, where x is now in the domain of g. Does that make sense? Yeah, I know it sounds complicated, but if you think about it, that's how it should be, right? That's what we will call an odd extension. So I guess that should make sense, right? So yeah, and the negative f of negative x, what's that going to be? It's gonna be just negative x squared, negative to positive, so plus sine of x, and then negative natural log of negative x, right? Because natural log of -1, we can't deal with that right now. So yeah, I mean, that's why a is the only one that works. Cool. So to fourth, even extension, okay, of this guy, right? So once again, the same kind of scenario, but now the thing is that it should be positive f of x, right, over here. So yeah, I mean, just put negative x instead of x and let's see what happens. And then change the domain to negative infinity to 0. Make sense? Cool. Just put negative x over there. It's like x squared and then negative sine x and plus natural log of negative x. And that should be doing it. There we go. That's the even extension. And the domain is negative infinity to 0. Make sense? And where is that? Okay, C is the answer, I guess. Next question. Fifth. F of x is a real valued even function and the number of real value of x necessarily satisfying this. Okay, real valued even function. Real values of x necessarily satisfying this. Wow, that's weird. Okay, I mean, two possibilities are already there, that you could just have x minus 1 upon x minus 2 is equal to plus minus x, right? That's, yeah, going to give us all of the obvious roots, right? But what if it is not a 1-1 function? then that's a complicated thing, isn't it? Okay, it's already not a one function, but okay, what if some y equal to something line cuts it at 4 points, or 5 points, who knows, isn't it? Yeah, then how do you even do this thing? The minimum values, right? Minimum number of values that you can have. Well, we can figure that out, sure. This is so weird. Like, what if, say, f was cosine? If it was a periodic function, then what? Right? So cosine of x is equal to x minus 1 upon x minus 2. What does that mean? That just means like x minus 1 upon x minus 2 is equal to plus minus x plus the plus some kind of integral multiple of the period. So plus n times the period. In this case is 2 pi, right? And yeah, there's going to be infinite number of such values, right? What if it's periodic, right? Number of real values of x necessarily satisfying. Oh wait, okay, necessarily. I guess that just means the minimum number of values that will satisfy. So yeah, maybe that's what it means, because necessarily, right? Okay, that should be good, right? So if it's even, then at least this must happen, right? So whenever x minus 1 upon x minus 2 is equal to plus minus x, this works, right? This equation satisfied. So let's solve this thing. Yeah, like just put plus minus over here. X square minus 2x is equal to or let's just say plus minus of x minus 1 is equal to 0. So first thing would be x square minus 3x plus 1 is equal to 0, and the other guy would just be x square minus x minus 1 is equal to 0. So right, this is just first guy, we just want number of values, right? Oh yeah, sure. But still, just figure this out. So x is equal to minus b. It's going to be 3 plus minus 4 of b squared is 9 minus 4. This is just, yeah, 5 upon 2. So that's these two values. And then x is equal to minus 1 plus minus 4 of b squared. Minus 4 is just, 5 ones again, and that thing upon 2. But yeah, like these can't be the same in any case. Which means, yeah, 4 distinct values that necessarily satisfy this equation. So C might be the answer. Next question. Sixth. If there was not this word necessarily, then yeah, this would be not solvable. But there is this thing. A real valued function satisfies this equation, and f of x is so there is one way that I know to do this thing. Okay, you could apply natural log on both sides, and okay, what if it's not positive? Oh, yeah, what if it's not positive? That would be problematic, isn't it? Yeah. How do we know if f of x is positive or not? Well, let's just say natural log of mod of whatever this thing is. So if we define g of x to be natural log of the mod of f of x, right? Then you can clearly see that g of x plus g of y is equal to g of x plus y for all real values of x and y. What does that mean, right? And is it continuous or what? Okay, nothing is given. Oh god, see, wait, okay, they are using some other g of x. Okay, maybe I should use h in that case. Well, whatever, just for this once I'm going to use g without caring about what they are giving us, right? In that case, of course, this function would just be, so natural log of mod of f of x, this function would just be k times x, right? If it is continuous, that is. What if it's not continuous? Yeah, that's kind of complicated. Oh, and also they actually have f of x not being equal to 0. Then of course you can do this thing, that's law of mod of f of x. Sure. Okay. What if it's not continuous? Then that's problematic, right? Because then this, yeah, then this equation doesn't make any sense, because you can't take partial derivatives or whatever, and yeah. Oh, that's problematic. Really problematic. Well, anyway, I mean, a guess would be, this thing is equal to kx. So what does that mean? F of x is just equal to a e power kx. Wait, something's going wrong. It's e power. No, it's like plus minus e power kx. That should probably work, I guess. Which is basically like plus minus a power x, right? I guess. Okay, that's what f is. And right, what else are you saying? Oh, and by the way, f of x times f of y is equal to f of x plus y. So if this is negative a of x, then that won't work, right? There's only one way. It should be positive f of x. Sorry, positive a of positive a power x. What am I doing? Right. Then g of x is this thing, a power x minus 1 upon a power x plus 1. Guess what? It's odd. Yeah, a. Just put negative x in there. It's going to be 1 minus a power x upon 1 plus a power x, right? When you do all algebra. Cool. Next question. Seventh. Seventh is f is an even function and equation of tangent to the graph of y equal to f x at 2 comma 0 is y equal to x minus 4. Then the equation of tangent at negative 2 comma 0 is even function equation of tangent to graph at y equal to f x at 2 comma 0. Okay, is this. Then at negative 2. Oh yeah, okay. So just think about the graph, right? Okay, why am I even doing that? It's actually pretty easy. F of x is equal to negative f of x for, sorry, it's an even function. F of negative x, right? This is true for all real values of x. What does that mean? If you take the d by dx on both sides, basically it just gives us f dash of x is equal to negative f dash of negative x, right? Which means at 2 comma 0, if the slope was 2, then at negative 2 comma 0, it will be, negative 2, right? Yeah, so y equal to negative 2 x plus some kind of constant. So, as this point, negative 2 comma 0 actually sits on this, you can actually figure out what c is, which, let me guess, is just negative 4. We don't want that. Right? So, just put negative 2 comma 0 in this, like, but 0 is equal to 4 plus c is equal to negative 4, y equal to negative 2x negative 4. That's the tangent. So basically 2x plus y plus 4 equal to 0. Or 2x plus 5 equal to negative 4. Both work. C should be the thing. Cool. Next. Inverse of the function. So negative infinity to negative 1 to negative infinity to negative 2. Wait, what? Okay, so only less than negative 1 works. Less than negative 2 works. So inverse of the function f(x) is equal to negative x squared negative 2x minus 3. It's like negative x minus 1, so x plus 1 squared and minus 2. So if this is equal to y, right, negative x, and by the way y is already negative, so yeah, so just make that positive or whatever. This is going to be equal to negative y negative 2 basically, right? So yeah, I mean y is already negative. Okay, you should write this as negative of y plus 2 because y plus 2 is also less than or equal to 0. Okay, strictly less than 0, right? Was y is less than negative 2. Cool. What does that even mean? That means like this thing is actually positive, which makes perfect sense because it must be positive. And then x plus 1 is just the square root of all of that stuff. Wait, no, it's the negative square root of all of that stuff because yeah, it's less than 0. So negative square root of negative y plus 2. What does that mean? X is the inverse. So f inverse applied on y basically, right? So what that means is f inverse of x is equal to negative 1, negative square root of negative of y plus 2. That's a bunch of negative, right? Yeah, I guess b should, actually, if it's x, then it should be x over here as well. Makes sense. Okay. So b should be the thing, I guess. Yeah. Ninth. Ninth is inverse of the function, this function to negative 1 comma 1 fx is equal to this guy. Inverse of this function. Oh, it's only going from pi upon 6 to 7 pi upon 6. Okay. So like, okay, what about x plus pi upon 3? So x plus pi upon 3, where does that go from? 30 plus 60 degrees, that's 90 degree to 7 pi upon 6. Okay, 9 pi upon 6, I guess, right? Which is 3 pi upon 2. So some angle in these two quadrants, right? Okay. You want sine of that guy. Of course, it's covering all of the. It's 1 as well, and it's onto bijection as we think. So yeah, right. It's just gonna be that. So you want something related to sine inverse. Oh, so if you got how do I say this thing? Right. So for this angle, right? So x plus pi upon 3, whatever this thing, theta. Yeah. You got this sine theta value. The sine inverse thing is actually going to give us this guy, right? So we don't want that guy. We actually want this complete thing, isn't that? So if this thing is just y, right? That sine of x plus pi, let's call this theta. Who cares? Sine of theta is equal to y. We want to figure out what theta is, but we know it's like theta is just not equal to sine of pi. We can see what it's going to be actually. Isn't that right? Yeah. Like call this thing alpha. I don't know. So this would be alpha, right? Sine inverse of y is alpha. Then what is this complete angle? It's pi minus alpha, of course, because yeah. So pi minus sine inverse of y, right? At least that works for this this quadrant. What about this quadrant? So once again, it's gonna give us this guy, right? So it's negative and everything. So negative sine inverse of y, that would be a positive angle, which is exactly what this angle is. So pi plus that, basically, which is like pi minus sine inverse of y. Makes sense? Yeah. So it works both of the times. That's why this is the thing. So where is the... Oh, and by the way, that's theta. So theta was just x plus pi upon 3, isn't that right? What does that mean? X is just equal to 2 pi upon 3 minus sine inverse of y. So the f inverse function is just 2 pi upon 3 plus sine inverse of x. Make sense? Cool. Which is C, I guess. Hey, they even made this bold as if they're giving us a hint or something. Okay, next. 10th question. 10th is the inverse of the function real to real plus f of x is equal to 10 power x plus 1 is. Okay, 10 power x plus 1. You want the inverse of this function? Hey, it's not that hard actually. If you just got like y is equal to 10 power x plus 1, there's only one thing that can happen. That's natural log of, log, just log base 10 basically, of y. That's going to be equal to x plus 1. So, x must be log base 10 of y minus 1. That's the only thing. Cool. Yeah, yeah, that should be the thing. So, where is it? I guess this one, A. Cool. Next. This was much easier than what I expected. Okay. Inverse of the function negative to infinity to real. Okay. Weird. Negative 2 to infinity. So it's like all the ones that are bigger than 2. Negative 2, sorry. Fine. F of x is equal to 1 plus natural log of x. So x plus 2 is this positive. That's why this thing makes sense. So y equal to 1 plus natural log of, yeah, basically y minus 1 is just equal to natural log of x plus 2, isn't it? Of course, x plus 2 has to be e power y minus 1. Makes sense. So x is negative 2 plus e power y minus 1. So what's the f inverse function? Negative 2 plus e power x minus 1. Easy as that. So e power x minus 1 minus 2, which is d, I guess. Next. 12. Inverse. Okay, I'm just gonna do it right away without even. Yeah. So 1 upon y will just be 2 power negative x plus 1. So 1 upon y minus 1 equal to 2 power negative x, right? So negative x is equal to log base 2 of negative x is equal to log base 2 of 1 upon y minus 1, right? Yeah, I think that definitely that should work out. So x is just equal to negative log base 2 of 1 upon y minus 1, right? So negative log base 2 of basically 1 minus y upon y. So f inverse is yeah, this thing, just replace this by that. So this is f inverse of x. Makes sense? Okay, and let's just log base 2 of x upon x, x upon 1 minus x, I guess. Right. So A is the answer. Next question. Don't even look at the domain or anything. Yeah. 13th. For the function real to real, fx is equal to e power x, and g real to real, g of x is equal to 3x plus 2, domain of g of f inverse of x. Wow, interesting. So the domain of that guy. Uh, Basically, you're asking what is the range of this, function g of f of x, because only in that range will the inverse function even work. Makes sense. What if it's not bijective? It must be. That's a linear function. That's an exponential function. It has to be bijective, right? There's only one g of x, and then once you know what g of x is there, from that value to the f of g, oh, you're going g of f. Doesn't matter in the end. Okay, so 3 e power x minus 2. That's what, g of f will be. This guy is belonging in this range, -2, not inclusive to infinity. That is the range of g of f, which means it's also the domain of its inverse, right? So C probably. Next question. 14th. Uh, okay, if real to real, f is real to real, fx is given by x cubed plus a plus 2 times x squared plus 3x plus 5. Wow. A plus 2 you are saying. Interesting. Why did you do that? Oh, there's no 3 over there. That's very weird. What if I try to complete the cube or something? No, not easy to do. It's an invertible mapping. Find A. It's already on 2. We just need this to be bijective, and the only way a cubic can be bijective is that it must be monotonically increasing, right? So that means 3x squared plus 2 times of a plus 2x is taking a derivative plus 3a. This must be bigger than 0 or equal to 0, right? Inflection points are allowed. So yeah, this must be bigger than or equal to 0. What does that mean? Discriminant must be less than 0. So a plus 2 square, I mean, I'm going to cut down that 4 part. So yeah, okay, minus 3 times 6 is 9a. That must be less than 0. So like a square plus 4a minus 10, so 5a plus 4 is less than 0. So a just belongs to 1 to 4, I guess. Cool. Inclusive, well, it should be less than or equal to 0, I guess. So inclusive, yeah. Cool, which means B is probably the answer. Right, so what happens if it is in fact equal to 1? Right, what if A is 1? Then it just becomes x cubed plus 3x squared plus 3x plus 5. And yeah, it's going to be just like x plus 1 cubed plus 4. If this is equal to y, there is really just one way, cube root of x minus. So like, yeah, the cube root is well defined for all real numbers. So you can always do that. And then, yeah, there's only one thing that x and b, and that's why it's good. Same stuff when it happens before, right? It's still good. Cool. Next. Right, so it's some kind of cubic function, right, plus some constant. Cubic, okay, a cube function, not a cubic function. Whenever you have 1 or 4 as the values. Was, yeah, at those points, there's, right, one point where the slope becomes 0. So there's an inflection point, basically. That makes sense. Next question. 15th. 15th is a function, okay, 3 upon 2 to infinity to this thing, okay, defined by f of x is equal to x minus 3x plus 4 number of solutions of the equation. F of x is equal to f inverse of x. Ooh, interesting. Number of solutions of this equation. Okay, so 1, 2, 3, 4. Huh. Very interesting. I mean, okay, it's from 3 upon 2 to, hey, so like 3 upon 2 is the, yeah, the extreme value of this guy, right? That's when you get the minimum value, and then from there it's just increasing throughout. Sure, so it's monotone increasing in this domain. And 7 upon 4, I guess that's the value at 3 upon 2. So that would be the minimum value, I guess. Cool. Right. Sure, and then you just want f of x to be equal to, what if I just, graph this out or something? So 3 upon 2 is 1.5 somewhere over here, and then 7 upon 4 is 1.75. Okay, which This is 1.5 and then 1.757. Okay. This point is there. Okay. And then from there just increases like that. Cool. And then, that's f of x. What about f inverse of x? So whenever you have the graph y equal to f inverse of x, that's basically saying x is equal to f of y. So just, yeah. Sure. So like just switch the places of x and y. Isn't that right? Just want to take a reflection basically, right? So you got, some point x naught, y naught on that. That is just by this equation. Y naught is equal to f of x naught. Then think about the point, y naught comma x naught. That will satisfy, this equation. Call this thing as x1, this thing is x, this thing is y1. Then this will satisfy this equation that x1 is equal to f of y1, right? So basically just take the reflection about, y equal to x, and then we'll see what happens. So something like that. So it can either not touch, or maybe if it does touch, then you will have like two intersections or maybe one intersections. So it can be 0, 1, or 2, right? Yeah. And then all of these, numbers, right, wherever these intersect. Okay, this is kind of complicated, isn't it? Uh-huh. It really is. Where would these actually intersect? Wherever they intersect, there's one thing for sure. Y is equal to x, and at the same time f of x, sorry, x is equal to f of y, right? And then, yeah, f inverse of x is just y, basically. Oh, that didn't actually, that didn't actually do anything. Yeah. Ah, yeah, that didn't do anything. Okay, we need to do something about it. Okay, just come on, do it. Okay. So x plus minus 3x plus 4. What if I just put that inside it? Oh god, it's gonna be some kind of pi quadratic. Am I even going to solve that? Why even solve it? Just say this is like f of x is equal to 0. Sorry, no, not 0, equal to x, right? So, oh no, not good. This is looking not good. Uh, is there no way to solve this? Come on, think. What if like, okay, I take the derivative of the difference of these two. So f of x minus f inverse of x. Right? What about this guy? If I take the derivative and see if it's, who am I kidding? We know it's either, yeah, you could probably just have two solutions, or one solution, or zero solutions. 3 and 4 definitely don't work. But are we sure it's 2 and it's not 1? Yeah, we don't know. One thing's for sure, but that by symmetry, this is going to happen at x is equal to y, right? On that line. So, okay, at x equal to y, you will get that thing, right? Cool. So just have to figure out when does x equal to y intersect with the y equal to x graph. Yeah. Wait, are we sure it's correct to say f is, that x is equal to y is the point where it's like, okay, how do we know it's going to intersect on x equal to y? Okay, you got this thing, and from that, what do you even get? Oh god, this is very weird. Okay, something like that. God, this is not helping me. Yeah, it's not helping. You could just write down what fx is and write down what fy is, and then try to solve the system of equations. Maybe that's better than solving this equation, right? Who knows? Maybe that is better. So yeah, well, let's try to do that. So it's like y is equal to x squared. Where did that go? Where did that go? X squared. Wait, what question am I solving? Okay, this guy, right? 15. X squared minus 3x plus 4. and then x is just equal to y square minus 3y plus 4. Now from this, can you like figure out any special stuff about this? Like if it's on some kind of, this is not helping. Uh, hmm. Take a difference of course. So if both of these are true, you can just take a difference. That's gonna be like y minus x is just equal to x minus y square, just x minus y times x plus y minus 3 of x minus y, right? So x minus y common, and then you got x plus y, right? This minus 3 is minus 4. No, that's gonna go over there, x minus y, so like minus 2 basically. Minus 2. Yeah, that's equal to 0. Can this thing be equal to 0? That's the thing. Can that actually be equal to 0? So look at this domain, right? It's 3 upon 2. So of course, like what does that even mean? That means that x is actually 1.5. I mean, it's bigger than or equal to 1.5 for this whole graph, and then similarly for this whole graph, y is going to 1.5, right? So it's just the reflection of that. Isn't that right? That's what f inverse of x is. Uh, yeah, right. Okay, it's defined on the range, I suppose. Something's weird about that. It should be defined on the range, isn't that right? Yeah. I mean, 7.4. Is it not defined on the range? It must be. Messed up somewhere. Whatever, the main thing that I'm saying is that x and y both are bigger than 1 at every single point, right? Because the range of this function is 7.4. That's like, okay, that's bigger than or equal to 1. Domain is also bigger than or equal to 1, right? What does that mean? When you do the f inverse thing, only these values will actually be in the domain. So the domain is already, the domain is already, God, what was it doing? Bigger than or equal to 1. Does that make sense? And then once again, the range will be bigger than or equal to 1 because, yeah, well, whatever. Hey, isn't 7 by 4 less than? No, it's bigger than that. So it also works out. Okay, so this is maybe just a coincidence or whatever, but x and y both turn out to be bigger than 1, which mean x plus y minus 2 is necessarily positive. So this cannot be 0. It's only one way, x is equal to y. Cool. And now once you know that, it's just a piece of cake. Just 2f of x is equal to x, and you will get the thing. So it's really just x squared minus 2x plus 4 is equal to, no, that's equal to x. So it should be negative 4x over there. Negative 4x plus 4 is equal to 0, right? Yeah, that's when you will actually get a solution, right? If this happens, so if y equal to x, yeah, you can figure out these two guys. That's when this is going to happen, right? If x will actually be equal to x, then these 2 points automatically satisfy this equation because x is equal to y. That's what matters. Okay, so you solve this thing, and the number of solutions will be the number of solutions of the equation f of x is equal to f inverse of x. And the discriminant for this guy is 16 minus 4 is like minus 16 equal to 0, which means there's only one solution, which is x is equal to 2, of course. So only x equal to 2 and also y equal to 2, right? So 2 comma 2 is the only point that sits on this guy. So what that means is, yeah, like only x equal to 2 is going to be the solution. So there we go. 15th answer is A, 1. This was weird. I mean, I had to overanalyze this thing. I could have just solved the biquadratic. Who knows? Maybe that would have been the easier path. Or just said by symmetry, y equal to x. But yeah, I did prove it. That's a plus point. Okay, that's done. Let's check answers. First D, second D, third A, okay, C, C, A, then C, B, C, H, A, D, A, okay, then C, B, A. Cool. Well, all correct. I like that. Next. Yeah, we don't want that. We'll do that. How many questions? Just 10 questions? Sure, we can do that. Let's do it. So what's this, functional equations? I don't know. Okay, let's do it. First question, if x is sorry. First question, if f of x times f of y is equal to f of x plus 5 for all real x and y, and if of 1 is equal to 1 upon 2. Once again, we know it's something like a power x, right? That's the only kind of function that satisfies this equation, right? I mean, I showed you how that happens in the previous exercise. So, okay. And f of 1 is equal to 1 upon 2. Okay. So, a is just equal to 1 upon 2. So, it's like 1 upon 2 power x, basically. That's what f of x is. Then summation from r equal to 0 to infinity of, oh, come on, see, it's like 1 plus 1 upon 2. Yeah, that's going to be 2. You know that. So A is the answer. That's a very, well-known thing. 1 plus 1 upon 2 and so on. That thing is supposed to be 2. So first A. Second, f of x plus f of y is equal to f of x plus y plus 1. So what I'm guessing is, just do minus 1 on both sides. Right? So actually 2 times of that. So f of x minus 1 and then plus f of y minus 1 is equal to f of x plus y minus 1. Makes sense? Just did minus 2 on both sides. So split it as minus 1 on the left hand side. Right? And what does it mean? That if I define g of x to be f of x minus 1, then g of x is just following the Cauchy equation, which means g of x is something like kx. Right? There we go. So f of x is equal to kx plus 1 and kx plus 1. And what they are saying is f of 2 is equal to 5. So 2k plus 1 equal to 5. K must be 2. So it's really just 2x plus 1. Then f of 100 is 200 plus 1, 201, which is C. Next question. Third. Number of solution of 5 fractional part of x is equal to integer part of x, where this denotes the okay. So basically, like fractional part of x is just equal to integer part of x upon 5. Now integer part of x can be, I don't know, 0, 1, 2, 3. You get the idea, right? This must be positive first of all. Yeah. So the integer part has to be positive or equal to 0. So you could just have this thing being equal to 0. It could be 1, it could be 2, it could be 3, it could be 4. Can it be 5? Well, no, because fractional part of x cannot be equal to 1 or higher. So yeah, that's what this guy can be. And then correspondingly, you will have some fractional part of x. So, this thing, right? Once you know this and that, you can build up what the actual x value is going to be, right? This is equal to x, by the way. So yeah, there we go. So should I even write that down? Maybe I should. So 0 plus 0.5, that's 0. Then 1 plus 1 upon, you get the idea, right? Do I really have to write that down? So how many solutions of this guy? Well, 5 solutions. Easy as that. Right, so B is the answer. Next question. Fourth is the range of f x is equal to 3. What is this? Are these bracket or integer part of sin x? No, these are integer parts. Okay, so GIF of sin x plus 4 GIF of cosine x. Oh god. Well, one thing we know is that sin x, cosine x, well, those the greatest integer functions of that, well, those can only have some certain values like -1, 0, and 1. Only those values, right? Only those values work. Yeah, okay, so let's start, in fact. Right, so I guess -1, -1 is going to be negative. Right, so if both are negative, so in the third one, what, let's just do it like this. I'll go quadrant wise. So the first one, okay, let's use these points as well. At this point, sin x is 0, cosine x is 1. So this whole thing is just 4. Then in this region, both are, fractions. So it's 0. Then at this point, sin x is 1, so it's 3. Then in this region, cosine x is negative. Sin x is still a fraction, positive fraction, that's equal to 0. Okay, right? The greatest integer function of that. And the greatest integer function of cosine x, that's actually equal to -1, so it's going to be -4 throughout. Sure. And then at this point, cosine x is -1, so it's going to be once again just -4. Sin x is 0. No worries about that. Then for this region, once again, cosine x is negative and everything, so it's -4. and sine x is also negative, so it's -3, -4, which is -7. And at this point, uh, at this point, sine x is -1, sine x is 0, so right, 4 times 0, and then 3 times -1. That should work. It's just going to be -3. And in this region, once again, sine x is just a negative fraction, so -3, and then cosine x is 0. So there we go. So what's the range? 0, the start of negative numbers. -7, -4, -3, then 0, then 3, and then 4. Right, that's the range. So where can I get that? -1. Well, no, that's not right. What is this? 7, like both being, no, that's not possible. Okay, -7, -4, -3, 0, 3, 4. Right, A is the thing, I guess. Next question. Fifth. Fifth is the following represents a homogeneous equation. Expression, right? So x squared plus y squared, and then suddenly there's a 1. No, this does represent homogeneous equation, right? This doesn't, because x squared plus 1, degree 2, degree 0. How can we do that? B is the thing. Next question. Sixth. So the following implicit relations can represent y explicitly as a function of x. This, no. This, okay, natural log of x times y, that's equal to 1. Wait, x and y both must be positive. That's important. But I guess you can actually represent it as a function of, yeah, I mean, okay, natural log of x times y is equal to 1, so x times y must be e power 1. So y is equal to e on x, right? Of course, the domain is just, 0 to infinity, not inclusive, right? So I guess second can do it. So second is allowed. What about the third one? No, once again, you got squares. So you got some x naught y naught value. You got x naught negative y naught value as well, doing the same thing. Oh God, why did this happen? Wait a second. Yeah, just wait a second. Wait, what? Why is this not? Oh, please, not at this moment. Oh, okay, fine. Right, so yeah, we're back. Sixth, it can. So second one can actually do it. Third, cannot. Fourth, e power x plus y plus. Yeah, this is the linear equation. So, e power x, call this thing u. U plus 3 is equal to 2u plus 2 basically. So like u is just equal to 1. E power x plus y is equal to 1. So x plus y must be 0. That's the only way out. Y equal to negative x. Makes sense. So fourth can do it. So second and fourth, right? Which is option D. Next question. Seventh. Seventh is if f of x times y is equal to f of x plus f of x times f of y. So f of x is not equal to 0. And what is this? F of 2 is equal to 4. Then f of 10 is, that's interesting, f of x times f of y, that's equal to f of xy. Let's once again define a new function. Like just say g of x is equal to, okay, so we want the inside to be split apart, right? So we just go with f of natural log of x. Yeah, right. That's not the best way to know. Okay. What about like e power x? Okay. Yeah, that's gonna work out actually. So let's go with this e power x. Right, that's gonna work for all this. And natural log of mod of this guy. That, sure. So then what's g of x plus g of y? That's going to be like natural log of f of e power x plus natural log of f of e power y, which is basically natural log of f of e power x times f of e power y, right? The mod of it, of course, which is just f of e power x times e power y, which is like f of e power x plus y, mod of that, of course. What does that mean? It's just equal to g of x plus y. So g of x is equal to kx because it satisfies the Cauchy equation, which means this thing is equal to kx. So f of e power x, that was basically something like a power x, or yeah, right, a power x, that should probably, or e power ax, who cares, e power kx, I don't know. Yeah, the k is just some number, we don't know what that is. Makes sense. Cool. And after that, just replace e power x by x. So you just put x as natural log of x instead. So it will be f of x is equal to e power k natural log of x, which is basically x power k. So x power n is the kind of format that we look for. So the function f must be something like x power n. Makes sense? Yeah. Okay. So then f of 2 is 4. X power 2 is equal to 4. Oops, no. It should be 2 power n because x power n, right? It's equal to 4. So yeah, n should just be 2. Makes sense? Right. So x squared is what f is. Okay, then f of 10 will just be, 10 squared is 100, which is d. Next question. I know some of these arguments are not very formal, but who cares? We're just solving these, not writing a complete proof for that. 8th. 2f of cosine x plus 3f of sine x is equal to x, then f may be. So maybe, is that real? Oh god. Oh hey, I think I know a way to do this thing. So let's just call f of cosine x as, u, and f of sine x as v. So what we actually have is 2u plus 3v is equal to x. Now what I'm going to do is, instead of x, just put pi upon 2 as x in this whole equation. So then that's just going to give us 2v, because f of sine x will be over here, right? Pi upon 2 minus x is cosine of that guy, sine of x. Plus 3u, that's equal to pi upon 2 minus x. Yep. Just add these up. What do you get? 5 times of u plus v, because, okay, that is equal to pi upon 2. So basically u plus v is just equal to pi upon 10. That's perfect. And you could also subtract this or something. Yeah. Subtracting, just get, why even do that when you can just do this thing? Yeah, we just say v is equal to pi upon 10 minus u. Put that in there. So 2u plus 3 times, that's like 3 pi upon 10 minus 3u, that's equal to x. So u is just equal to 3 pi upon 10 minus x, I guess, right? But remember what u was, it was just f of cosine x. So f of cosine x is equal to it's equal to 3 pi upon 10 minus x, right? That should be it. So what if just said x is equal to, so x is replaced by cosine inverse of x, right? What if you do that? And that's like saying f of x is equal to 3 pi upon 10 minus cosine inverse of x. It could be this thing, right? That's the thing, it could be this thing, not that it will necessarily be, but yeah, who knows, it could work. You can also have like x replaced by negative cosine inverse of x, and that would basically give us 3 pi upon 10 plus cosine inverse of x, and it will still work. It will still work, sure. Okay, so it's really just plus minus over here actually. Interesting. And 3 pi upon 10 is not here. Why? Why is that not there? Pi upon 5 or something. Oh yeah, you can actually write this thing as pi upon, so like 5 pi upon 10, that's 5 minus pi upon 5, and then plus minus cosine inverse of x. So what I'm guessing is that it's got minus in one of these ways. So sine inverse of x minus pi upon 5. That would have worked, right? So it can be this guy, which is b. Next, 9th. It should really just be, like plus 2n pi or something like that, but whatever. We just want a can be, not it will be. Okay, 9. F of x is a polynomial function specifying this equation. F of x times f of 1 upon x is equal to f of x plus f of 1 upon x for all x belonging to real except 0. Okay. And f of 3 is equal to 10. Then f of 4 is. Uh, right. Think about it. What would be the degree of okay, I should not say degree because that would not be polynomial function. Who cares? So we'll just say something like a sub polynomial. Who cares, right? So you just expand this thing f of x times f of 1 upon x. After expansion, what's the highest x power that we'll get, right? That's what I'm calling a degree. So suppose f of x was of degree n, then this would of course have the highest degree being n as well, right? It can be n. And then similarly over here, okay, that makes sense. Once again, the highest degree can be n, lowest can be 1 of, yeah, okay, and sorry, highest can be n, this will be negative n. Yeah, sure. That isn't doing anything. Yeah, I don't like that. We didn't get what kind of function that is through this thing. Something else. Oh well, I think this might work. So f of x, f of 1 upon x minus f of x minus f of 1 upon x, that's equal to 0, right? What I'm going to do is plus 1 is equal to 1. Now this whole thing can be factorized as f of x minus 1 times f of 1 upon x minus 1. I don't know if this is going to work or not. I'm just going in, seeing what happens. Sure. So wait. What you're saying is it's equal to 1. Interesting. F of 1 upon, hey, yeah, I mean, that's pretty obvious. The only way that this could be is that both must have a single term. Exactly. So like, oh god, it's very weird. It's equal to 1, you are saying. Uh, yeah, that's very weird. I just said that the leading degree was n, right? So for this guy, right, this whole polynomial, it's got like x power n plus some stuff, a x power n plus b x power n minus 1, whatever. And then finally you come to a constant c. Now for this guy, just putting 1 upon x instead. So, it's like a and then x power negative n and so on. Same constant c. When you multiply these out, you should not get terms which are not constants basically, right? Yeah. So when you will multiply this out, right? Okay, those must just turn out to be 0 or something like that. That's weird. What's the leading term? How did we get the leading term? Of course, this times that will give us the leading term. That must not be there. What does that mean? That this constant must not be there, right? Or maybe like a is not there. Well, wait, if there's no constant working, it's kind of weird. And also the fact is that what it's actually saying is that f of 1 upon x, let's just call this thing as g of x, right? This whole thing as g of x. So basically g of x times g of 1 upon x is equal to 1. So g of 1 upon x is equal to 1 upon g of x, right? What kind of polynomial does this thing? A single term, a monomial, of course, right? Only that, because if you got more than one terms, you can never do this thing. Yeah, you cannot. Even if you do partial fractions of whatever you want, there's no way you're going to write it like that. Yeah, no, that doesn't make sense. That cannot happen. The only way this is actually going to happen is, right, these must be monomials, right? So then it's just ax power n or something, and of course a is actually just plus minus 1 because only then will this work coefficient wise. Cool. So really, like g of x is just plus minus x power n, where n is some number. Okay, and then f of x will of course just be plus minus x power n plus 1. Cool. So what we are doing is f of 3 is equal to 10, right? In this thing, what does that mean? Plus minus 3 power n plus 1 is equal to tenth, like it's equal to 9. It cannot be negative, so it has to be positive, right? Yeah, that's resolved right now. And then you got 3 power n is equal to 9, so n must be 2. That's the only way. Cool. So f of x is really just, x squared plus 1. Makes sense. F of 4, that's going to be 16 plus 1 is 17. So C is the answer. Next question. 10th. 10th. 10th is if 2 f of x minus 3 f of 1 upon x is equal to x squared, then f of 2 is. Okay, so, pretty much the same as what we got previously. Just call f of x as u. So you got 2u minus 3v is equal to x squared, and then instead of x, just replace this by 1 upon x. So you got 2v minus 3u, that's equal to, what was it once again? 1 upon x squared. Yeah, sure. Just add these up. So you'll get negative u plus v is equal to x squared plus 1 upon x squared. And then you can also subtract. So you'll get 5u minus 5v is equal to x squared minus 1 upon x squared, something like that. So u plus v is just equal to negative x squared, negative 1 upon x squared, and then u minus v is just equal to 1/5 x squared minus 1 upon 5x squared. Then just add these, so you get 2u, right? f of x is what we want, of course. So 2u is just equal to negative 4/5 of x squared minus 6/5. Wait, is that right? It must be x squared. Cool. So u is just negative 2 upon 5x squared minus 3 upon 5x squared. So f of x is basically this thing, right? It's negative. Wait, that's not supposed to be. It's 1 upon x squared, sure. Wait, something went wrong, didn't it? Yeah, okay, that's x minus. It's supposed to be 1 upon x squared. That's what went wrong. Okay, this is gonna work out. It's gonna work out like this. Cool. So it's gonna be just negative 1/5 of 2x squared minus, not minus, plus 3 upon x squared, right? Makes sense. What we want is just wanna kill this guy. Wait a second. Okay, so what do we want? We want f of 2, just put 2 in there. Negative 1/5 of 2 times of 4 is 8 plus 3 upon 2 squared x 4, right? So negative 1/5 of 32 plus 3 is 35 upon 4 is going to be just negative 7 upon 4, which is A. Next question. That's done. Next. Answer key. Okay. First is A, then C, then B, A, and 5th is D. What? 6th D, 7th D, 8th B, then C, and then A. Okay, so why is 5th D? Should finally represent a homogeneous equation. So is this not representing a homogeneous equation? Sorry, expression? What? How can B not be? I mean, this is weird. This has the same degree as that. What's going on? Maybe something with definition, right? Maybe I'm just thinking of very casually. I shouldn't think of that casually. Okay, so none of these. Well, whatever. Okay, cool. Then you got solved objectives. So more inchapter exercises are there or not? Okay, just keep on scrolling, keep on scrolling, keep on scrolling. Oh yeah, so this is I solved this when I first got this whole booklet. So I unfortunately didn't make videos on that. So I should have made videos, but I missed that opportunity. And I only solved one of these exercises. Yeah, I mean, this chapter is just completely theory based. It's not having any practicality, right? It's the kind of chapter that, gives you an overview of, what you'll be learning in general, not what you'll be learning in particular chapters. Makes sense? Cool. So I guess that's enough. Let's see you guys in the next video.